Well, hey guys. Hey, welcome to 9.2, and we're just going to continue in our linear relations chapter. And this lesson is a little bit harder than the last one, so you'll really need to watch this video, I think, to really just get what's going on with the graphs. This will be our last lesson for this week, and we should be able to move on next week. So you have lots to work on and to practice. We're just going to start here with some things of talking about the terms in math. And so the first word that I want to talk about just before we get into things is the word variable. And the word variable basically means a letter. So usually it means like X, Y, A, or B, right? The letter that's there that represents an unknown amount. So what you have here in this statement is 3A minus 5. And the variable is the letter A. So variables are letters. When they use the word expression in math, they're talking about like a formula or a mathematical statement involving numbers and letters, so involving numbers and variables, but it doesn't have an equal sign. So it's usually just some sort of a formula without, or a statement without having an equal sign. So x plus 9, 2y minus 7, or 8t. These are expressions. They're not necessarily formulas, they're just expressions. Formulas come in the form of just having like a y equals here, but expressions are just a little bit shorter. They mean the same thing in the sense that they both are solving for variables. It's just that when we talk about formulas, they usually have more than one variable. So in this particular chapter, we're identifying relationships in tables of values and in graphs. So we did this last time, and so here this says the pattern in the table of values represents a linear relation. Graph the ordered pairs in the table. Okay, well, so we're not going to worry too much about that here, but I have the answer right here. Here's the graph. So remember that your first part of the table here is the x value, and the second part is the y value. Remember that the x-axis goes on the bottom, that the y-axis goes down the top, and these are coordinates. So you'll notice 0, 0 is here, 1 and 3 is here, 2 and 6 is here, 3 and 9 is here, and 4 and 12 is here, making a linear equation or a linear graph. The second question says, what's the difference in values for consecutive A values and for consecutive B values? You're going to see this in your textbook, so I just wanted you to know what that means. What is the difference in value for consecutive A values? Okay, so looking here, guys, right here, this is how we answer the question. All this question is asking you for, the difference in value for consecutive, is the pattern in the letter A part of the table and in the letter B. You're just looking for the pattern. So when we look at this, we go from 0 to 1, well, that's plus 1. From 1 to 2, plus 1. From 2 to 3, that's plus 1, and we continually go up with plus 1. On the B side, it's plus 3. 0 to 3 is plus 3, 3 to 6 is plus 3, 6 to 9 is plus 3, and so we notice that the pattern in the B end is plus 3. And so it says, what's the difference in values? Well, the difference in consecutive values for A, for this side of the table, was plus 1. And the difference in consecutive values, which means consecutive means just moving up just by one part of the table. So the difference in consecutive values for B is 3. So the pattern is 1 and 3. And then it says, describe in words the relationship between the values of A and B. So you need to know that when A increases by 1, right, B increases by 3. So that's the pattern. So when A is moving up by 1, B is moving up by 3. That's how we answer this question. And then down here, the most important question right here, what is the expression or the formula for B in terms of A? So we were looking at this last time, and what we saw was y equals x. Remember that when we look at the pattern, we're looking at the y value at the second part of the table. We're looking for what's the pattern in this part of the table. So remember that we use this pattern number right here, and then we put it beside the x. Or in this case, we would say b equals 3a. Because it was asking you to write an expression for B, which is why it's B, or y equals, right? So B equals 3, that's the pattern, A, 3 times A, or 3x, like what we were doing last unit. We were so if you haven't already done the last page and you're popping in right now, you really need to go and understand how to write this part of the formula, because we know that we're just looking for the pattern number here. It was 3, we placed it beside the x, and that's perfect. Or this one would be B equals 3a, okay? So here's a you try. And so it says here, the table of values represents a linear relation. So then the first question says graph the ordered pairs in table of values. So in your homework or whatever, it might ask you to graph something. I'm not looking for the most immaculate graphs, you guys, so don't worry about that if you don't graph paper. 3, 4, 5, 6, 7, 8. So this 1, 2, 3, 4, 5, 6, 7. You'll notice my graph is beautifully stunning, and that's my x, and that always goes on the bottom. My y's go up by 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. And I'm just going to start here, 5, 10. I'm just going to go 15, 20, 25, 30, 35, 40, 45. Okay, so that's just me putting in the values here. Graph the ordered pairs. So 1 and 5 goes here, 2 and 10 goes here, 3 and 15 goes here. It looks like we're going to get a linear relation, and so we can just continually graph, and that's what we get. And 7 would be up at the 35. So I'm just graphing these ordered pairs here, all right? Just making sure that you know what I'm graphing. What's the difference in value for consecutive x values? So now we're just looking at the x table. We're not looking at anything else right now, and we're looking in for the pattern. So what was the pattern from here to here, here to here, and here to here? Well, from 1 to 2, it's plus 1. From 2, so it looks like we're just, the pattern, the difference in values of consecutive is positive 1. It goes up by 1 every time. B says, what is the difference in, what's the difference in consecutive, y value? So now we're looking at the pattern here. So what's the pattern up here? Looks like it's going up by 5 every time. And then C says, describe in words the relationship between the x values and the y values. So we say that for every one x value, right? So that's right here, the y moves up by how much? 5. Cool. So the next part here that you'll do in your textbook is determining whether something is or isn't a linear relation. And this is super important, all right? So we want to know whether something's a straight line or whether something's not a straight line. That's what that means, okay? So the first step that you do is you're going to look at the pattern in the table that you've been given. So that's what we're doing right now. If the patterns are the same for every number, then the graph will be linear. It will be a straight line. So guys, when we take a look over here, we saw that this table, the x values go up by 2. Yes, that's also by 2. 4 plus 2 is 6. 6 plus 2 is 8. This table goes up by 2. 3 plus 4 is 7. That's correct. 7 plus 4 is 11. That's correct. And 11 plus 4 is 15. So this table is linear. Let's look at table 2. Table 2 goes up by 1. 1 plus 1 is 2. 2 plus, yeah, this is perfect. Let's look at this one. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 1 is 8. This one is throwing off the table. This one is making the line not straight. It's not linear. Therefore, this graph right here is not a linear equation. That's super important, and the only way you find that out is by looking at every single pattern and noticing, there's something off right there. If the pattern of the y spot, of this spot right here, the second part, is different, the graph is not linear. Now, guys, listen, I need to tell you something really important, and if you're listening and reading these notes, I need to tell you that if up here in the x value, if it goes up and it's a little bit different, it does not necessarily mean the graph isn't linear. You can have values that go from 1 to 4 and 5 in the top, but you can't have it in the bottom. It just doesn't work that way. So the bottom has to be the same, or else it can't be a linear line. So looking here, coming down to step 3 here, it says if the pattern of the y is different, then it's not linear. So the pattern was plus 3 here, but then bam, you get this plus 1. This is not a linear graph. So that would be no. So when we look at this here, here's the graphs of what we just looked at from this table. And I can just show you right now that the pattern went up by 2 here, so it's a linear graph. You notice how it makes a straight line. But check out this one. It goes up by 3, 3, and then 1. Look at what happens to the graph. So that's not linear, so this is not a linear equation. That's how you figure out if something is a straight line or not. So here's a you try. It's really simple. We're just going to do it together. Determine whether each table represents a linear relation. Explain how you know. Okay, so the first thing we're going to do is look at the top. We don't need to worry so much about the top. We're worrying about the bottom. But let's look at the top anyways. This goes up by 3. This goes up by 3. So this part checks out. This part goes up by 9, and this part goes up by 9. Because both of them go up by the same number, that's a linear graph. So that graph is going to look like this. Table 2, let's look at the same thing. Looks like we're going up by +1 every time. On the bottom, we went up by 1, 2, and 3. So this graph is not linear because these values need to be the same for it to be linear. So you have to have the same numbers in this y in the second part of the table there in order for it to be linear. So this is where it all boils down to, guys. This is the biggest, beefiest part of this unit, and it's writing a linear expression or writing formulas. You have to know how to do this next year. You have to know how to do this in grade 10 for about 40% of your unit. So let's take a look at it and really think about it. First thing I want to say, anytime you have a chart looking over here, you always want to know that the first part of the chart represents X, the second part of the chart represents the Y values. We need to take a look at the values on the top here. Great, they go up by 1, and then we need to find the pattern in the Y, which is the most important part and the one that you find the pattern in. +2, +2, +2, +2. We did this last time in 6.1. What is an expression for the cost of the relation to the number of enlargements? So it's asking you for the formula, aka write the formula. So the first thing we did here is we found the pattern. We found the pattern in the bottom part of the chart. And so what we got was +2. Step 2, write the statement. You did this last time in 6.1. Y equals 2x. Why? Because this is the pattern number and it always goes beside the x value. Step 3, check to see if we need to add to the statement by interpreting a number from the x line. You guys, this is where I want to say that what's happening is sometimes the graph y equals 2x is not enough. It's not the actual formula. And we saw last unit that sometimes you'll have things like +3 or 2x minus 4. Sometimes the linear equation looks different and it has two sets of values, not just y equals 2x. This is where you have to watch. So guys, 2x might not be the correct answer. How do we figure out if this formula is correct from the graph? This is our new step now for this unit. What you do is you take a number from the top, and I'm always going to take the first number, whether it's 0 or 1, whatever it is, it's the easiest one. I'm going to take this number and I'm going to stick it in to the x value. So what I've done is I've taken number 1 here from up here and I've slotted it in to this x spot. And I did the math for it. So the formula was y equals 2x. Okay, so I put in the x spot this 1. So I went y equals 2 times 1. And I get 2 times 1 equals 2. Now looking here at the graph, it's not supposed to equal 2. It's supposed to equal 3. So guess what? That means that you need to have something more and add something more to your formula. So looking again here, check it out. We did the same thing. It equals 2, so we're not quite there. We need to get to 3 here. So we need to have 2x plus 1. That's the correct formula because y equals 2 times 1 was 2, and then I needed to add 1 to get to 3. So let's check it out. I put my 1 value right here into the x, and I did this math. I did the new formula math. So 2 times 1 was 2, plus 1 equaled 3. And now my table works. Now guys, listen, this works with any number on the top. So just to show you, you don't have to pick the number 1, or what if the number 1's not there? I'm going to just, for the sake of it, pick this 3. Y equals 2x plus 1. What you do is you take this 3 and you slot it in where the x was. Y equals 2 times 3 plus 1. Then we do the math. 2 times 3 is 6 plus 1. That equals 7. Guess what? This formula is the correct formula because look it, that's the answer you wanted. It works for any one of these numbers on the top to substitute for x. But that's how we decode. It's kind of like a game. You're decoding and trying to figure out what is the formula for this particular answer. So the first step was that you went in and you got the pattern of the y value down here. Okay, the pattern was plus 2. You did what we did last unit, y equals 2x. The second step, that's the most important step, this isn't necessarily the right answer, right, is we went and we solved that. We took a number out of the table, so let's take 4 for this time. Y equals 2 times 4, and that equals 8. Well, guess what? That's not correct. We have to get to 9. So that's why we have to go y equals 2x plus 1, because 8 plus 1 is 9. And now this is your formula. So looking back here, and this is actually how we do it in grade 9, it only works when your x values go up by 1. And when I'm looking at your practice examples in your textbook, it looks like there's some that do go up by 1 and some that don't go up by 1. So this is really only going to work if it does. But what we do is we find the pattern here, and you don't have to know how to do this, but I'm just going to show you really quickly. We might do this a little bit later, but you find the pattern in the y values. So what we did is I wrote it down, and so 3 plus 2 is 5, 5 plus 2 is 7, so here's your pattern, and you put it up here in this little spot right here, multiply by 2, and this is the pattern number. So then I come down here and I write y equals 2x. Then how I figure out how to get the rest of my answer in grade 9 is I go and I look from this number, then I have to go like this. Then I have to multiply this multiplier number, that's why it says multiply, by all these numbers in here. So 2 times 1 was 2, 2 times 2 was 4, 2 times 3 was 6, 2 times 4 was 8. And so that's how I got this particular part of the table, the multiplied by number. And then I went backwards and I went like, how do I get from this 2 back to this 3 right here? Well, I had to add 1. And that's how I got this particular add 1. See, 4 plus 1 is 5, 6 plus 1 is 7, 8 plus 1 is 9. And so my new formula is y equals 2x plus 1. That's how we get it in grade 9. It's about the same thing, but it only works when you have the x value here goes up by 1. So the next question that was asked in that big problem was, what is the cost of 15 enlargements? So if I look back here to the graph, the number of enlargements is here, and the table only went up to 5. So I want to know how much it's going to cost if I extended the graph all the way out to 15. How much would it cost for 15 copies? So really, we don't need to like write the graph and the table 600 more times. All we need to do is plug in this number 15, right, into our beautiful new formula, y equals 2x plus 1. So 15 was, enlargements was, we go back here and we notice it's part of the x column, so that's where we put our 15. So that's why in here, okay, that's part of the x column. So I went 2 times 15 plus 1, and I just threw this number right into my formula, and then you do the math. 2 times 15 is 30, 30 plus 1 is 31, and that's your answer. So that's how you input information into your formula. But you have to build your formula first, and then you can do that. How did I know where the 15 went? Well, I went here, and I took a look at my chart, and you notice here, this is the x, and this is the y. It said enlargements, so I knew it was where I put it into the x value. So the 15 was, I knew I'd put that 15 right there into the x value. Hey guys, so I made a mistake on my other video, so I'm snipping this into this video just to make sure that this gets right. It's actually kind of a hard question, and I did it really fast, and I got it wrong, so it's worth an explanation here. Anyway, so here's the table that you have, and the first thing is you're supposed to copy and complete the table, but we already did that, so no big deal. We can just fill in the rest here because we know that the pattern is adding by 20, it looks like, on the bottom here. And so we can just add by 20 to get these other little deals here. So that would be an 80 in this box and 100 in this box. Okay, is this a linear relation, and how can you tell? Well, the top went up by 5 every time. So that was good. And remember that it doesn't necessarily have to go up on the top by the same. You'd have to graph it to check. But both of them do go up by the same amount. The bottom goes up by 20 every time. And so because of that, we're good to go. So the answer is yes, this is a linear relation because they both go up by the same. This is where things get a little bit weird. What is the expression for Sky's pay in relation to the number of subscriptions? This is where I went wrong in my initial video. If you watched it and you're watching this correction, and if you didn't watch it, well, it's my bad. But anyway, so this is a little bit of a harder table because when you draw it out, I'm just going to draw it on this side. You have 0, 5, 10, sorry. 0, 5, 5, 10, 15, 20, and 25. Okay, and then on this side over here, on the Y side, you have 0, 20, 40, 60, 80, and 100. Now, what's important to notice here is that like the X side right here doesn't go up by 1. And so when that happens, it's hard to build a formula. So actually what you got to do is you got to take a look at what's going on in this graph. And it is going up by 5s. Remember we said that, going up by 5s. So, right, so everything's going up by 5. So we want to bring the graph back down to being 1, 2, 3, 4 in order to be able to make the chart that we did like up here in grade 9. See how this is 1, 2, 3, 4. Everything that we've been doing is 1, 2, 3, 4, 5. But this one's weird because it has 0, 5, 10, 15, 20. So if I divide all of these numbers by 5, so if I divide 0 by 5, so I'm just going to put this over here and I'm just going to say I'm going to divide all these numbers by 5. So 0 divided by 5 is 0, 0 divided by 5 divided by 5 is 1, 10 divided by 5 is 2, and you'll notice that if I do this, 15 divided by 5 is 3, 20 divided by 5 is 4, and so on. And then I'm going to do the same thing to the other side of the table because it's only fair just to see this. So 0 divided by 5 is 0, 20 divided by 5 is 4, 40 divided by 5 is 8, sorry, 8 here. We got 60 divided by 5 is 12, and 100 divided by is, sorry, so then, where am I? Sorry, everything's going on here. 16, so it's 80 divided, sorry, 16. 80 divided by 5 is 16, and so on. So here's my new table that I built from this table. Okay, I divided everything by 5 to bring my x-axis back down to 0. Now I'm actually able to figure out the pattern because it goes 0, 1, 2, 3, 4. So now I can go back to like what I was doing and I can look at the pattern and I can say, okay, what's the pattern? It's plus 4, plus 4, plus 4, plus 4. Okay, so now I build my equation, y equals 4x, and I check, right, to see if this is right. So I input. So I'm going to go y equals 4 times, and I'm going to choose this 5 right here, times 5, and that equals 20. Does the 5 equal 20 on the bottom? Oh, it does. So guess what, you guys? The answer here is y equals 4x. So that's the formula, but I had to bring this like top part here, I'm just going to highlight it here, bring this part here to being 1, 2, 3, 4 right there. All right, so you want to make sure that you bring the top down to being 0, 1, 2, 3, 4, and then it's easy to find the pattern. So I found my formula, and because I found my formula, I can now do D, which says how much does Sky receive for selling 40 subscriptions? Well, I remember that subscriptions is in the X and that pay is in the Y. That means that I'm going to put the number 40 in the X spot. So Y equals 4X. So Y equals 4 times 40. And 4 times 40 is 160. So that's how much money she makes for 40 subscriptions. So that's like the hardest question you'll have to do, I think, in this unit, is just to recognize that if there's a pattern on the other side of the X, that you're going to have to divide it by that number to bring it down to being 0, 1, 2, 3, 4, and then divide it the same number. So since the pattern was 5 here, I divide everything by 5 on this side, and then I'm able to find the pattern right here. So that's kind of a hard question. I'm going to adjust my other video, but yeah, yeah, so make sure that you do that. I don't know how many questions on this particular page are like that, but there'll be others in the textbook that will be. So remember, if there's a pattern on the top, to divide by that number, and then you'll be able to find the pattern number and the formula. Cool.